In this video, we will be discussing second-degree price discrimination and more specifically, block pricing. Here is a problem where the electric company in the state of Michigan is implementing a block pricing model for each county with 2 blocks each. We want to find the prices, the quantities, and the profit given the following price function and marginal cost. And they give us a price function of P equals 250 minus 3Q and a marginal cost of 7. So what exactly is block pricing? Well, a thing that helps is to draw our graph. And we have our price function that looks like this, and our marginal cost function, which looks like that. So we have our marginal cost and our price functions, and these are on the price and quantity axes. And with block pricing, we separate our demand into 2 blocks. So we have 1 block and then 2 blocks. And so this would be P1, and this would be P2, and we would have Q1 and Q2. So depending on how much quantity a consumer consumes or uses, we would charge a lower price after they pass a certain threshold. So if they use a quantity that's below our quantity 2, we would charge a price of around P1. But if they pass Q2, we would charge a price of P2 after that point. And we want to figure out our profit. So if we were to visualize which region represents our profit, it would be this area that is underneath the blocks. So we could find this area and then we would find our profit as a result. But we would need to make sure not to double count this area. And we could also represent P1 and P2 using our original price function. So we would have P1 equals 250 minus 3Q1, and we would have P2 equal 250 minus 3Q2. So after all that information, what we can do is now we can form our profit function, which is P1 times Q1, or the area of our first block to get our profit, plus P2 times the quantity of Q2 minus Q1, which is the area of the second block, which is our profit, and we take out the area of the first block that intersects with the area of our second block, so we don't double count, and then we subtract out marginal cost times Q2, so we take out our costs. And so plugging in more information, we can plug in our prices as well as our marginal cost. So we get profit equals 250 minus 3Q1 times Q1 plus 250 minus 3Q2 times Q2 minus Q1, and then we would subtract out 7Q2. So this is one long profit function, and it'll only get longer from here due to how many terms we have. And so by distributing, we get a profit function of 250 Q1 minus 3Q1 squared plus 250 Q2 minus 250 Q1, and then continuing, we would have minus 3Q2 squared plus 3Q2 Q1 minus 7Q2. So again, this is one long profit function, and we want to make it smaller somehow. So we would combine like terms and see where we could cancel terms out. So right off the bat, we can cancel these 250Q1 and 250Q1 right here because it's adding and subtracting the same number, so they go away. And then we could combine this 250Q2 and negative 7Q2. So after combining some like terms, we get a profit function of negative 3Q1 squared plus 243Q2 minus 3Q2 squared plus 3Q2 Q1. Now, since we're using a different approach to profit maximize than our traditional marginal revenue equals marginal cost, we would have to profit maximize using the derivative of the profit function set equal to 0 to profit maximize, because at our maximum point, our rate of change is 0 because we have reached a maximum point. But since we have two different variables, we would have to take the partial derivatives, or the derivatives with respect to each variable. So first off, we'll take the derivative of profit with respect to Q1. And so that derivative ends up being negative 6Q1 plus 3Q2 equals 0. And if we were to solve for one of the variables, so let's say we'll solve for Q2, we would add 6Q1 to both sides, and we would get 3Q2 equals 6Q1. And so if we divide both sides by 3, we get Q2 equals 2Q1. Now, if we take the derivative of the profit function with respect to Q2, we get 243 minus 6Q2 plus 3Q1 equals 0. And we figured out what Q2 is, so we can substitute what that is into our function. So we have 243 minus 6 times 2Q1 plus 3Q1 equals 0. And by multiplying out, we get 243 minus 12Q1 plus 3Q1 equals 0. And then if we combine like terms, we have 243 minus 9Q1 equals 0. And then we would add 9Q1 to both sides. And we get 243 equals 9Q1. And we would divide both sides by 9. And so we get a quantity 1 of 27. And now we want to find quantity 2. And we know quantity 2 equals 2Q1. And so 2 times 27. And if we multiply that out, we get a quantity 2 of 54. And so, since we have found our quantities, we can now find our prices. So, starting with P1, we would take our original price function of 250 minus 3 times quantity 1, which we know now is 27, and plug that into a calculator to get a price 1 of 169. And we would do the same thing for price 2, which had a similar price function of 250 minus 3 times quantity 2, which we know now is 54, and we get a price 2 of 88. So, consumers that fall under the block for P1 and Q1, we would charge them $169 per quantity, or in this case per kilowatt hour used. And for the consumers that fall into the second block, we would charge them $88 per kilowatt hour used. Last but not least, we can find our profit, and if we look back at our original profit function of P1 times Q1 plus P2 times the quantity Q2 minus Q1, and then subtracting out marginal cost times Q2. And so if we plug in what we know, we get a profit of 169 times 27 plus 88 times 54 minus 27 minus 7 times 54. And if we plug this all into a calculator, we get a final profit of 6,561. So, for whatever county this electric company is in, they would charge $169 or $88 depending on the consumer and how much electricity they consume. And they have around 54 customers that fall into the quantity block 2 and 27 customers that fall into block 1. And so after all is said and done, they make a profit of $6,561. Now, if we were to look back at our graph, we can look at our surpluses. So, unlike previous price discrimination topics, block pricing does not have the assumption that the producer takes all of the surplus. So there's some consumer surplus when it comes to block pricing. So what we can see is this area of the blocks, that represents our producer surplus. It also represents their profit because there is no fixed cost in this situation, only marginal cost. And as a result, this entire profit area is also our producer surplus. Now for consumer surplus, these triangles above the blocks are technically our consumer surplus. So unlike previous price discrimination topics, consumers actually gain surplus here. That will conclude this video on block pricing.